Hi everyone, in this video we're gonna master Socket.io with React.js from 0 to hero. Yes, you're here right. This whole video we're gonna take Socket.io course from scratch. I'm gonna learn everything about Socket.io, from connecting and creating a server using Node.js and Express, from connecting to a React or from a React client to a server and handling all these connection errors. We're going to learn more about rooms and namespaces and all that sort of stuff. We're going to see how actually Socket.io works behind the scenes and just like see the low-level API of handling rooms and managing or joining and leaving a room and basically handling of like how many sockets or how many clients are connected to the room and all the sort of stuff that goes about or behind the scenes about Socket.io and being able to handle it properly between a browser connection and a Node.js server, all in ease in a single video. And of course, we're going to take all of this fundamentally from scratch and starting from scratch with real-time bidirectional and event-based communication library as cool as Socket.io basically. And eventually, so we're going to just like have this introduction. Of course, we're going to go through the way and we're going to learn all of this by creating a multiplayer online game, and it's going to be a tic-tac-toe multiplayer online game. So that's what we're going to be creating here, and this is basically how it would look like finally, where the user is going to have like the choice to join and choose a game room ID, so he can input his own custom game room ID. He puts it that way, and of course he can share it with his friend across the board, in an online, of course, across the country or across the world, and they can both use the same game ID. They can join and they can play tic-tac-toe, and of course you can handle all of this in real time, and it can change and it work perfectly. So in here, for example, if you choose like from this opponent, like go for game one, you say like waiting for all the players to join, and let's go for the other player. We import the same game room, we click join, and now they are both joined. They can start playing. As clearly, this one cannot. So this one can start actually playing. For example, it can start clicking here. So clearly in real time, it shows up. Now it's this guy's turn. This one cannot play anymore. You can go with an O, for example. So you can click like puts O there. And for example, this one like puts another one like X. So clearly it being updated in real time in a really cool manner. And that's really performance, and it all happens real time. Those instances are separated from each other. Those are like different tabs, so they act as different users at different networks, whatever. It all gonna happen. We're using the help of Socket.io on a Node.js server, of course. So for example, let's say this O guy is gonna be winning. I'm gonna put an X for this guy, and I'm gonna put an O in here. So you see you get like U1. Of course, you can customize it however you want, but you got U1 in here, and of course that all works pretty well. And of course you can actually have it all working pretty much fine and just like manage all of that. So of course there's much of features you can add to this game. It's just like a basic bare minimum game, but it all works in real time, bidirectional, and of course using Socket.io with React and TypeScript. So that's going to cover throughout this video. Hope you guys enjoyed this one, and without further ado, let's go ahead and get started. So let's go ahead and get started, and first thing here, as you see, we need to go into the Socket.io website, and this is the official website of Socket.io. Now, for those of you who doesn't know what Socket.io is and why it does have this much of hype, why everyone talks about Socket.io, why everyone, whenever you hear WebSockets, you find Socket.io kind of like on the top of the list, it's kind of crucial, right? It's very fundamental, and it has a lot of like popularity among a lot of developers, and it's very great. Now, what is Socket.io? Socket.io is actually a real-time bidirectional library that allows you to use mainly, I'm going to say mainly because it's not always relying on WebSockets, but mainly going to allow you to use WebSockets to allow two communication ways between a client and a server. And what I mean by a two communication way, it's basically the client can send a request or like an event, and the server can send back another event. And if you say, oh, HTTP works that way, yes it does, but it's not the way that you think it is, the same as Socket.io or as WebSockets. It's completely different because HTTP can allow the server only to send back a response in just like a small duration of time. If you're familiar with like timeout in HTTP, well, that happens because when you send a request from a client to a server has only like a set amount of time just to process the request and get with a response back to the client as soon as possible. He can pretty much like wait an hour, then send back another request. That's impossible. Let's say you want to like upload something, like upload a very huge video file for processing on the server. You can't allow the user to just send an HTTP request and wait for that file to be processed, because the file will probably take like 3-4 hours, maybe a day, maybe has a queue, a lot of like stuff that can happen behind the scenes over there. So a socket IO or a two communication way is pretty much needed. And this is what I mean. Like a two communication way can allow the server at any time, as long as the user is actually connected. Of course, it connected with along this line or this communication bundle. It pretty much can allow it to communicate freely with the client. And the client, of course, can communicate freely as well with the server. So that's the basic concept of how Socket IO works. I try to just explain it as briefly as possible, just giving you an example on how that kind of like works behind the scenes. And if you take a look in here on the official website, there's this like cool example, just like a couple of lines of code, like 10 lines of code, and you get this kind of example here working, and this all connected. Pretty much it's just like a simple application. Tells you, I think it has some tweets. So as soon as like a retweet happens on the Socket IO, I think this is all happening on the fly. They're using WebSockets, and it's basically real time. So if you hear Socket IO or hear WebSockets, just think of it as real time, and it all happens real time. So there's a much of like why you want to choose real time thing. Like, for example, if you want to do online gaming, real time is needed, and real time is pretty much a necessity. Otherwise, you can't do online gaming. You can't do online game with HTTP. There's like streaming that happens, as I said before, like large media files, some kind of stuff like that kind of handle. If you're familiar with YouTube Studio and how uploading videos and all that sort of stuff. Instant messaging, if you use ever WhatsApp or Telegram or any of that sort, that happens, and it works using WebSockets, and it works using this real-time kind of mechanism that WebSockets and Socket IO is based on. There's a bunch of stuff in here. So it has plenty of stuff. A lot of people use Socket IO. A lot of people love using Socket IO. And the main reason I love personally using Socket IO is because it's simple, reliable, and it provides you everything that you need to pretty much build your Socket server and clients from scratch without any kind of like hidden complexities or hidden APIs or that sort of stuff. It works, and it's pretty simple. Now, if you hear me like saying that and you say, what is the difference between a Socket IO and WebSockets, and why you're saying they're not the same? Basically, WebSocket is kind of like the mechanism. It's kind of like the protocol that allows you to do real time, but Socket IO is more like a library that is built on top of WebSocket. But not only WebSocket, there's other technologies involved, because it can actually go and fall back on other stuff if WebSocket is not available. It mainly works on WebSocket. So for now, if you just like set up Socket IO in your server with a custom client, it will mainly use WebSocket because that's simple, that's fast, that's pretty much supported by many browsers, and it does it really well. But it can actually go ahead and fall back to other engines, and that's the great about Socket IO. It always falls back if it doesn't find a support, or if it does fail, or if you want to specifically tell it to fall back to that specific engine and use a custom engine or something like that to do a specific job. That's what I love about Socket IO, and that's what a lot of other people are interested and love Socket IO. So enough like talking about all that sort of stuff, let's go ahead and try to get something working with Socket IO in here. And the first thing we need to get started with before jumping any further is actually setting up a project that we can work with. So a Socket IO, as I said before, it's mainly about the server. So the server is actually the central point of truth where we just like send and receive data, send and receive events, and connect to, and all that sort of stuff. So we're gonna need a server, and the server that Socket IO works with is a Node.js Express server. So that's going to be creating here. It's just like a full Express server. Next, we're going to create a React application with TypeScript as well. And TypeScript is going to be involved in both parties. So it's going to be involved in the server and the client. And we're going to use this part just to make it statically typed. I'm going to use the power of TypeScript, just do a lot of other stuff and really awesome stuff, especially with Socket IO decorators and using class components. So it's all gonna happen pretty good and in a magical way. So without further ado, let's go ahead and get started. And first, we need to set up the project we're gonna be working on. Now, the project we're gonna be working on is actually an Express and Node.js set before. I'm gonna use the Express generator, which is just a CLI that allows you to generate and scaffold and ready-made Express projects that you can just hook up, open up your IDE, and you can start working with. So we can go in and use npx and do like Express generator, and you can give it a name in here, like whatever, like my app or something. Click enter, and this is actually going to grab the Express generator. It's going to start and it's going to pretty much create all that sort of stuff. As you see, you already did. It already has that. It's pretty fast just doing that. Now all you need to do is go ahead and cd into that directory and run npm install or yarn install, whatever you want to do it. In fact, I already did all of those. I already set up a project. I already started it. I already opened an IDE working with this. So it all works with me really well behind the scenes. So that's the project I got in here. And if you see a slight difference, this project is just simply the .ts extension here because it uses TypeScript instead of JavaScript. Now, Express Generator only comes with JavaScript support, but I just added this TypeScript support my own way. Of course, you can completely ditch this, but the way we're going to be using Socket.io today is actually going to be quite needed for this to use, because you're going to use something called decorators, which are only available through TypeScript, kind of like an experimental feature. If you're familiar with that, kind of like decorators in JavaScript and stuff like proposals and all sort of stuff in ECMAScript. But whatever, so that's the point in here. And just setting up a TypeScript is pretty simple. Now, for the installation parts, for setting up more specifically TypeScript, all you need to do is go ahead and install Node TypeScript. So it's typically here the TS Node, and this is going to allow us to run Node.js code using TypeScript. It's just like an interpreter made for TypeScript with Node. That's it. That's for granted. That's all you need to think about. Now to install this, do yarn install or yarn add TS Node, and make sure to add this as a development only dependency. So just add dash capital D and you're good to go. Also, make sure to install TypeScript, otherwise it won't work for you really well. You might also want to install NodeMon, which is just a node monitor kind of engine that allows you to restart the server whenever any kind of file or whenever something changes on your code. So the server is going to up and running with a new version that you have changed and saved. So that's basically all we need for that particular case in here, just NodeMon, installing TypeScript and then those sort of stuff. So it should be all good in here. Just click enter and they should be only installed in that particular case. So we're good to go from that part. Now the second part we need to worry about is actually installing Socket.io and actually going and setting up Socket.io. Now for that one, what we need is actually yarn add and socket.io. And that's all you need in that case. Just click enter and you're good to go. And this is going to install the server version of Socket.io, because the Socket.io has two versions. It has the server side version and it has the client version. And this one is the server version, and you're good to go and get started with this. Pretty sweet, right? Alright, that's super good. And we actually can go ahead and get started. So first things first in here, what we need is pretty much create a new file. So we're gonna need to create a new file, and this I'm gonna name it this socket.typescript. So this one, what it takes care of, it basically the connection and opening this socket server and start listing pretty much for socket connection. So that's basically what it's gonna be doing for this one. And pretty much the paradigm I want to follow in here is actually exporting by default a function, then that function can pretty much take as an argument the HTTP server, because for creating a socket server, you need the HTTP server, the actual HTTP server that you already opened with Express and you already listing for your whole server. So that's basically the whole only requirement that it needs in order to pretty much create a server for Socket.io and start listing in. So for this one, what we need is actually export default, and we're gonna export an empty. And here I'm gonna have an HTTP server, so just we can get an HTTP server from the arguments. Now for this one, we can go and create do const and create and initialize a new one. And we need to do new. Let's go and import the actual server. So you need to import server from socket.io. And this server, we need to initialize or initiate this class, the new server, and you can pass it whatever options it is. So first one it takes is actually HTTP server, and the second one is like what type of options it needs. Now in our case in here, and I'm pretty much sure like a lot of cases is going to be the same way, is you're going to need the course options, because you're going to need to provide some course configuration for connecting to that. If you have like subdomains and multi-domains, or just like third-party domains need to connect to your API and consume it, well, you need course, you need to configure it properly, otherwise it will just like have a really serious bad, attacks and problems like XSS and all sorts of stuff. So for our case in here, I want to go ahead and follow and just pretty much allow course to be available all the time, and just like provide course. I think it's true. I'm not really sure. It should be a course. You should provide an object, and it should be an origin, and you just like do the asterisk in here, and you say, oh, for this origin or for any origin, just accept the connection, and pretty much we are actually good to go. So that's all you need to pretty much initialize and create your Socket.io server. Now for the server in this case, what we need is actually going and return the IO. Now, whenever like we require this socket in here and we pass in the HTTP server, we can get the instance returned back to us, and that should work really, really well without any issues. So that's all good from that particular side in that case. Now, the next one in here, what we need is pretty much like we can go ahead and use something really, really sweet that's going to allow us to use like class-based components, and we can just like have some decorators working around, just like to hook all of this like kind of like controls. Now there's this called like this library in here. It's called the socket controllers, and it's a really, really awesome library. I know it's not really that popular or something, but this library is socket controls. It allows you to actually use class-based controllers to handle WebSocket events, and it helps to organize the code really, really well. Because if you try to work with Socket.io without some kind of like a way to organize the code in classes and subclasses and using decorators, you're going to have so many mess, and you won't be able to organize the code really well. So using this one is going to allow us to actually create classes, and inside of this class you're going to have like custom methods, and since we're using TypeScript, classes are going to work really, really well. So we're going to use these methods, and each method in here is going to represent a specific kind of like event or an event listener, or just like using decorators. And here's clearly see we get the connected socket without even just like keep listening, or even we can get the actual Socket.io instance on every single class using like dependency injection. How cool is that? It's all going to allow us to do this using this awesome library in here. Now to install this one, what you need is actually to install the socket controllers. The second one, you need the reflect media or metadata, sorry. Now this one, what it does is pretty much going to allow you, or pretty much add the feature of decorators into TypeScript, and just like allows you to use decorators in JavaScript in general, because it's a proposal, as I said before, a proposal feature. It's not fully integrated into the actual core of ECMAScript and TypeScript and all sort of stuff. So it's still an experimental feature, and you need to install something like this to be able to make it work. Okay, so that's what we need. Let's go ahead and jump and see how that should look like. Now for making this, we need to go and do yarn add, and we need socket controllers and reflect metadata. Okay, click enter, and those should be installed for you. I already did install all of that. So as clearly see, yeah, just like for those of you, I'm sorry if I'm just like hiding this, but there you go. So you add yarn add socket controllers and the reflect metadata in here, and just like install it, and you're pretty much good to go. Okay, pretty sweet. Now we got both of these installed in here. Now the first thing that you need to go in and do in here is actually go in and import the reflect metadata, which I already got in here, and I already just like imported for this one to be able to work properly. So make sure to import this in a root level kind of place, which is like up TypeScript or the server or something like that, and you're pretty much good to go. So in this case in here, to be able to pretty much tell it that we want to use the Socket.io, or to initialize the socket controllers, we need to pretty much like have a function and pass in our instance in here. So later on you can use dependency injection. It allows us to create classes and all that sort of stuff in order to get started and be able to work with this properly. Okay, so for this one in here, what we need to do is actually do use socket server, and this one is going to be imported from the socket controllers. And this one in here, what you need to provide it with, the actual IO or the socket IO instance. And here it takes an object. Now this object has a controllers attribute. Now this controllers is actually a path where you store your controllers in your projects folder. And those controllers are going to be, of course, a class base and going to be annotated using some custom decorators, and they're going to tell them that these classes are going to be compatible with the actual socket controllers classes, which means they're going to be able to consume something like the sockets and be able to use some custom decorators, maybe the socket controllers, and grab the socket server and use dependency injection and all this kind of stuff. Now, for this one in here, you can go ahead and provide it with an array. And say, for example, we want to use our directory name, and then we want to go like, for example, /API, then inside of controllers, then anything that ends with a TypeScript, .TypeScript extension. Okay? Pretty simple, and that should make it work properly. Now, inside of the API folder in here, we can go in and do like create controllers, and inside of controllers, we can have whatever controller, and it should work fine. For example, we can have like a main controller, which can act as our main controller, whatever, just like controls anything. And for this one in here, we need to do like a socket controller, and this one is gonna basically be a decorator to annotate a class that this one or this particular class is gonna be pretty much a socket controller class. If you don't provide this like pretty much decorator in here, it won't work with you. Okay, now here I need to do like main controller, and just simply like this. And here you can have whatever method, so you can use like, for example, public. Since we're using TypeScript, so public and all sort of stuff are doable, and they are pretty much available and working absolutely fine. So for example, we can do like on connection. And this one, we need to use like a decorator. So we can do on connection. Okay, sorry. So I think this is going to be on connect. And in this decorator pretty much is going to turn this function as a handler or as an on connection handler. So whenever our socket is pretty much connected, whenever a new socket is connected to our server, like a new client is connected to the server, what happens, this method is going to be fired up thanks to pretty much this onConnect. Of course, you can use the same way in here if you go back to the socket in here, and you can do, for example, on or our IO server and say like on connect. Just like basically this is how you use it from this particular part, or you can use like on connection. I think the new API uses the on connection. So you give it a handler in here, and this function handler in here is going to pretty much run whenever a new client is going to be like connected. And this is actually a reserved event name, so you can't use this as a custom event name, but still this is going to be actually reserved by the IO server, the server you create in here. So whenever a new client, a new socket is connected to the server, this method is going to be fired up, and of course you're going to have the socket instance in here, and you can console log it or whatever. So this all can work really well, but still we can use it pretty much the brand new way, the best way possible in here, using class-based controllers and with decorators and all sort of stuff, which is super sweet. How awesome is this? It's just like pretty easy and pretty sweet to manage and work with. Now for this one, to handle connection, we can use another decorator, which is an attribute decorator, and this one can pretty much do connected socket. Is going to provide us with a connected socket, and we can use some types in here just to take the advantage of TypeScript what we use in here. So we're going to import the socket, and we can import socket from socket IO, and this is basically going to give us the socket IO, and we can have another one like the socket IO, and this will give us the socket IO server indeed. So we can have, for example, the server, and we can import the server from here. And this will be our main custom server, dependently injected to us without any problems. And for example, you can do like console log new socket connected or something, and you can give it like a socket.id. Pretty sweet. That's basically what you need to do to pretty much handle connection, actually start up a new socket server, and using this awesome class-based controllers with decorators, it makes it even simpler to pretty much manage that, which is like a couple of lines of code with a really easy to read and manage code. We can have this really awesomely made up without any problems. Now, to be able to test our server in here, first, we need to make sure that the server is actually started running, and luckily for us, we got a custom script in here that's going to do it all. So we got this start script, it runs nodemon, or the node monitor package in here, which start monitoring depending on the nodemon JSON in here. Now, what the JSON is pretty much saying is like, watch the SRC, so anything changes inside of the SRC is going to be reloaded. The extensions are JSON and .typescript, and ignore those are test cases. Maybe you want to ignore the node modules, whatever. And execute, so this is the main executed command. So it's going to execute tsnode to run TypeScript node interpreter, and it's going to run the SRC server. Pretty sweet and straight to the point. Okay, so let's go ahead and jump right into this and make sure that actually works really, really well. So we can do like yarn, and we can do start, and this should basically start us our nodemon server, and we got server running on port 9000 already, and of course the socket.io server has started as well, but I think we haven't included that, so maybe, yeah, I think there is no socket listing for that yet, but what we can do is actually to make sure that is actually running. Okay, so let's go ahead and have this one here, and I can do require, and I can do, or I think we can go and do like use import. So we can import socket server from @socket, and socket server. Then we can pass in our HTTP server, as I said before. And this, of course, is going to allow us and returns the actual IO instance. And if you like hover over this, you're going to be the actual socket IO server instance. Then you can use it. But this one should initialize the server and should start it. And indeed, we have got no issues or no errors are being thrown at us. And that's pretty good. And that's actually working really, really well. Sweet, we got the server. Now the second piece of part in here, or the second piece of art we need to build, is basically the actual client or the actual front end that's going to be connected and to the server, and just to basically test the actual server, how it works and how it runs and all sort of stuff. And plus, we can go ahead and take it and create the actual tic-tac-toe. All right, so let's go ahead and take this into the next level, and it's going to actually create this kind of projects and basically kind of like initialize everything and make sure it works using the create react app CLI. So you can use npx and do create react app, and we can go and make sure we use a template, which is the TypeScript template, just to set up and generate the project as TypeScript. And here, of course, you can provide it with whatever, like my app and everything. Click enter, and this is going to do the magic for you, which of course I already did all of those. Yeah, because I already got like a project's name with this. Like you can provide my app one already. It's going to like start installing packages and all this sort of stuff for you. Okay, that should be all sweet and everything. Now we got this project. Let's go and open it up. So that's the project that's actually already running, and it got like welcome to Tic-Tac-Toe, because that's what we're going to be building eventually. And that's just a simple, easy project that has no magic behind it or whatever. Just a simple, easy project, straight to the point. Okay, now if we go ahead and test this one in here and see where is our projects file in here, take a look on localhost 3000, and remember the server is running on 9000 port on our localhost, and there you go, we got this welcome to Tic-Tac-Toe, so no magic is happening or whatever, so everything is working fine yet, but there is no magic happening behind the scenes or something from that sort. So everything is looking good, and we are actually good to go and get started with that particular part. Sweet. Now to get started with this one, what we need is actually to install 2 packages. So I'm going to go ahead and open up a new, and for installing this one, we can do like yarn add, and we can do like socket.io dash clients, and this is pretty much going to be the client library that's going to handle client connection to a socket.io server. Next, we're going to need style components, and of course this one is optional. You can use Sass or like vanilla CSS or whatever, but I would love to use style components or CSS and JS just to style and create our custom styles. Sweet. Click enter, and that should be installed for you. I already did all of that magic behind the scenes before, so I don't need to do that anywhere, and we are actually good to go. So let me just get rid of these, busted terminals. I don't need them anymore, and we're actually pretty much good to go. Now to connect to a server, and this is just gonna be like a simple connection, kind of like show you how that actually is being done. So let's say they're gonna name this connect and wherever, and we're gonna use effects. And of course, whenever when do you want to connect to a server is actually when the component is mounted, which means on did mount component. So like your app is rendered and everything is mounted. So you start the connection, and of course you handle it. If any errors happens along the way, you console log them or show them to the user, and etc, and all this sort of stuff in here. But the main point, what I'm meaning in this is like you actually need to do it once and make sure to do it only once. Otherwise it just like breaks the whole chain of connection. It breaks your components and it tries to connect multiple times to the server, which is pretty bad. You don't want to do that, and you just like make sure to do it only once and once for all. Okay, now we call connect in here. Now instead of connect, what we can do is actually do const. For example, we're gonna have our socket in here, and let's go and import the actual socket IO that's going to do the magic for us. So I'm going to import, I think we got this all as IO from socket IO client. And if I take a look on this, I'm not sure, but I think you should just like do IO as of this import, or yeah, this import won't work this way. So maybe we need just like to import IO. Yeah, that's exactly what we need. And this one is going to be like a constructor, and it takes a bunch of options. And the first option is actually the URL of where the server is listed in. And of course, this has to be a socket IO server, otherwise it will fail with you. And you have just to provide it with that. So for example, our server is actually HTTP localhost 9000. And we just like provide it with this one. And for example, you can do like socket, or I think this is actually good enough, and it will make it look really good, and we'll test the connection and everything. So if I save this one, if I go back to the server, if I go back and open up, where is that? So if I go back, open up this, go back to the server, indeed we don't have any, I don't know, we don't have any kind of connection or something. Maybe that is not being called, or maybe the connection handler is not taking it seriously. That's doable. That can happen. So probably the main reason why this is not connecting, because here on our main controller, we need to make sure we export this, otherwise it won't work. Because if you don't export this, the actual controller or the socket controller engine won't be able to like import this on its kind of engine, and this won't work. So make sure to always export this kind of controller, and there you go. So as soon as we do that, we got a new socket connected. So as soon as we refresh that, we go back, we get another socket connected. If we like refresh it as many times as we want, we get a completely new socket connected, because like the browser is going to be refreshed. It's going to be like reinitiated, reinitialized, and the socket connection is going to like first destroyed and reconstructed, like reconnect to the actual server, and that's going to generate a brand new ID, a brand new identity for that particular socket, and so on and so forth. So that's basically what happened in that particular case, and we got the socket basically connected and everything. So that's all working really sweet. The socket is being connected, and as clearly seen here, that's pretty simple. That's not even that hard or something to take care of or like handle whatever. Now for actual events or how they work, just to take a brief understanding of how that event works. So basically you need to use like the socket main controller, like the engine in here, and like you can go in and listen for whatever events on the server, of course. So you can use the on, and you can have like a custom events, like whatever name in here, and of course on you have a function, they have a callback that's going to be called with a custom data, and this data can be anything, like an object. Always imagine as this data is going to be an object. Of course we can go and do like console log data, and of course this data is going to come from the client, who's going to basically like emit this event to the server. Now to take a look on this on how emitting works, so you can have a socket, and here we can have a listener on a basic event, which is the connect event. Otherwise we won't be able to do anything unless this is connected. So this connect is whenever this socket made and initialized and constructed the connection between this kind of client browser and the actual server. Now this one is going to be called, and we can actually register whatever other call action, we can do whatever. Now on here we can use the emit. And this one will allow us to emit a custom event with a custom payload. And what I mean by a payload is the data that we can send to the server that is listening for that particular event's name. Simple, right? Now here we can have custom events. I think I named this custom events. Okay, so we can have custom events and we can send it whatever data. So for example, in here, like say name Alex or something, and this should be like age 20 or 15, okay, 25. And we can emit this event. And here, as soon as this one runs, as soon as this one connects, the server is gonna receive this one, is gonna like do a console log. So we're gonna see this, we refresh, this connects, the server, so the server, for some reason the server is not doing that and it's not receiving this event. And actually here we need to listen for the socket, not the actual server, because this is the connected socket, the actual socket that connected. So we need to add the listener on that socket. So since the event is going to be emitted on this socket, so you can imagine this as a separate rooms are kind of like those tunnels. So each one has its own custom tunnel. So if you send an event on a specific tunnel, it won't be reached or it can't be read on another tunnel. That makes sense, right? So this is actually where the notion of rooms comes in. So this socket is actually inside of its own main room, like private room, and there's a bunch of other rooms that other clients are connected through. So you can't pretty much listen to a specific image on somebody else's room unless you join that room, of course. But yeah, each socket has a room, so you have to like pretty much listen for that event on it. So if we save this one, basically, and go back here, as clearly see the image message already been received because we got that on connection, but whatever. So as soon as the actual one is connected, we are emitting this message, and yes, we are getting it on the server because the listener is actually listening for that particular event, and the event is being emitted from our custom client in here, emitting this event with a custom payload as however we want it to be. Pretty simple. And that's making a lot of sense actually, is how that basically works behind the scenes. So I just wanted to go through this in a really simple, basic way of how Socket.io works and how events and works with that particular part. There's of course a bunch of other stuff that needs to be like, to be able to master Socket.io and fully understand how it works. You need to go through a couple of stuff like namespaces and rooms and all sort of stuff, which we're going to be doing along the way of creating our custom Tic-Tac-Toe multiplayer game. So let's go back to the server side in here, our server projects. And what we need to do is actually go and create a new controller, and this controller is going to basically take care of handling like joining a new room. So like if you're familiar with Tic-Tac-Toe, and more particularly Tic-Tac-Toe, since it's a multiplayer, it needs at minimum or at maximum 2-player playing. Of course they can play in multiplayer, but of course how it works is actually 2-player with like one with an X and the other one with a O, and of course they have just like to grab like 3 X's or 3 O's on like a diagonal or the same column or the same row, and this is how they win. It's pretty basic, but when it comes to like making this with a Socket.io as a real time and as a game that is distributed between 2 guys in a multiplayer way, that's a little bit tricky, and this is where rooms comes in, and more particularly Socket.io rooms to isolate different sockets. And when I say different socket, I mean different clients or different users connected to the actual server, and allows pretty much to isolate those in a specific room where they can only chat or talk and send events and send messages on this room privately without letting others know about those messages. And that's basically what we need in this particular scenario. We need to have like 2 users, which are 2 game players, connect with the same room to be able to exchange, like send back and forth the messages and basically play the game. That's what we want in here. So we're going to have a new controller, and this one is going to be like the room controller.typescript. And for this one, we need like a socket controller, so which means we need to initialize this. And I'm gonna export class room controller, and this is basically gonna be our main class in here. Now we're gonna have the on message, Now the onMessage handler in here, so this decorator, what it tells it is actually pretty much going to be like the same when you do socket.on and you give it this custom event, and of course you have it the listener. So that's basically what it is in here. You pass it in here the event's name that you need the listener to be listening for, which is the method we're going to be having right now. So for this one, I'm going to have like join game. And if you see me here having this kind of like naming convention with the underscore variable naming convention, because that's how Socket.io follows, and that's what I like to follow. Depends on the library and stuff like that, how we use it. And of course, since Socket.io uses this naming convention, I just like to keep it the same way in here. And of course, that's good because those are unique names, and separating those using underscores is better than separating those using spaces. So we are overall good to go. So we can have public in here. We can have a custom named kind of like method. For example, join game. And this one is going to take care of joining a game. As simple as that. Now, first, we're going to need the Socket.io server. So there's going to be the socket, and we're going to need the server. I don't know how, if I can grab this from the server of Socket.io. Okay, that's good. And did I have this as a Socket.io? Yeah, I don't need a column there. Okay, we need the two parentheses. So this is the server, and what we also need is actually the connected socket. So socket, I need to grab this from here as the socket. And last but not least, we will need the message body, which is gonna be our message. And of course, we can have any in here, so we don't need to care about like what the type of message, of course, because we don't know what it is, because it's incoming from the join game kind of like emit request or whatever. And here we can do, for example, console log new user joining room. We can just, for example, do socket.id just to give it like what user, which user is joining, or better say that I want to just like, print out the message in here. Now, as I said before, the idea behind this one is actually joining a game. So what we want is actually both of these users to join the same room, and to identify a room in Socket.io is actually identified by a unique room name. For example, game 1 or room game 1, whatever, just like a unique name. And they need both to join this room to be able to start the game and actually start exchanging messages back and forth between both of these players, and of course be able to play the tic-tac-toe game. So for this one in here, we need a couple variables. First, I need to know like what are the other sockets that are connected to the room that is here being requested to join on. So I want to do like connected sockets. And this one's variables, actually pretty much we can go in and use our server. So we can do io.socket.adapter rooms, and this adapter is actually the main rooms manager, or the main manager of the server. So here we can do like rooms, and this one is indeed a map of a string, which is like the name of pretty much the room and the other connected socket to it as a set in here. So the name in here, or the string, this one is going to be like the key, which is the room name, and the set in here is going to be like the connected sockets to this room, more particularly. So what we want to get the gets in here, and we can use the message, because how we're going to receive the room name is actually throughout the message.roomID, which is going to be provided with us. And this one should give us all the connected sockets to the current room. So if there's 2, 3, 4, this one is going to give us those connected sockets. Of course, in a much better scenario, you can have to pretty much protect your application and make it more authentic. You need to provide or actually facilitate and make authentication possible. So any player needs to authenticate first before be able to join any game or even connect to the server in the first place. So this all happens in an advanced way, but yeah. So we can go ahead and separate it and make it work this way. The second variable in here is actually the socket rooms. So like right now we got the actual socket, which is the currently connected socket. So what I want to know is actually how many rooms or what are the rooms this socket is connected to. So we get like the socket rooms, which is of our current socket, of course, right over there. So what we can do is actually can do array.from, And for this one in here, what we can do is actually go and do like socket.rooms. So this is going to give us the socket.rooms, but it's a map, remember. So we can use the values in here. It's going to return an iteratable. So this array.from is going to return, or pretty much like take this iteratable and convert it into an actual array, so we can use it. Now we can use the filter method in here to filter that. So for example, the room, and we need to have like the room not equals to the actual socket.io, because how that works, or how socket.io works, so any kind of like socket has a default room, which is its own private room, which is identified by the socket ID itself, if that makes sense. So what I'm doing here is actually filtering that, and we say, oh, if it's the actual socket ID, if that room name equals the current socket ID, just completely filter that. We don't need it. I only care about all the rooms that current socket is connected to. I don't care about the default sockets room, which is, you know, of course, the only socket ID. I don't care about that. I just need to care about the others. Sweet. Now we can go ahead and get started, and we can do our logic in here. Now the basic logic I want to check, I want to make sure that the socket is not connected to more than a room. So if it wants to connect, I want to make sure that the current socket is only connected to a single room and a single room only. And what I also want to do is actually the connected socket to a room can't go over 2. So the maximum, like only 2 users or 2 sockets can connect to a single room at a time. So that's just like a basic check-in before allowing any user pretty much to join a room. So to do that, I want to make sure go and do like socket rooms dot length, and for this one, if it's greater than 0, or if the connected sockets, and just like make sure this is not null or something, and connected socket dot size equals 2. And what that basically means, if it's equals to, that means there's already 2 users connected to this room, which means this room is full. So anybody that is coming to join this room, he can't, just completely ignore that. So we got this inside of our if statement in here. So we can do socket.emit, and I can emit room join error. And of course, this is a custom event we created, so you can name it whatever. It works well with you, but I like this name better. And here we can provide like an error. So for example, room is full or something, please choose another room to play, or whatever, pretty much. So just like a basic message to tell the user exactly what is happening behind the scenes. Now else, if the room is basically empty, or it has enough room and the socket is not connected to other rooms, now in this particular case, we can go ahead and connect it to this room. So we can use await, and to use await, we need to mark this method as an asynchronous method, and I can go ahead and do like socket.join, and I can tell it, oh, I want to join this socket to a room, which is of course the room that has been requested by that socket, which is denoted by the message.room ID. Sweet. Now just by like issuing this from the socket side and the join, so this socket.io kind of command is going to like join this socket to this room denoted by this unique name. Now, how socket.io works behind the scenes is pretty simple. If the room doesn't exist, it's going to go ahead and create this room and join the socket to it. If the room already exists and the room has other sockets connected to it, well, that's simple. It's going to just like take this socket and join it to that room and just like keep track of it. Pretty simple and pretty straight to the point. No complexities around the corner or something from that particular part. Sweet. Now we can go ahead and do like socket.emit, and for example, we can emit a message like room joined. So the client who requested to join can know, oh, we joined the room. That's pretty sweet. Or if in case of an error, it says like room join error, so you can display something to the user. Please choose different room name, or this is a room that is already full and started playing, or whatever pretty much happens, like how it works in that particular part. So all works pretty fine, and those are pretty simple on how to get started for like joining rooms, and how this is basically how rooms works on Socket.io, and how you can keep track of them and how you manage them here and there, and how join in. And of course you can leave a room using like the socket.leave, and you can give it the room name that is already joined by that socket, and it returns a promise and all sort of stuff. But that's basic way how that works. Now we got the joining mechanism in here, so we can go ahead and start it, and we can actually join our socket into a particular room. Okay, pretty cool. Now we got the room logics and joining a room and everything. So let's go ahead and actually create, or pretty much add the logic for like application, or for like front-end React application using TypeScript and everything. So for now we got only this test where he just like connects and tries to submit a custom event to the server, and just like testing over cases. Like that. So we're gonna completely just ditch this off. We don't need it anymore, and of course we're gonna just like start from scratch. So the idea behind this one, what we want is just basically for like creating a way for users to join any kind of room they want. So we want to give them the ability to just like type in the game room they wanted to just join into. So for example, if you want to play with the other player, with your friend or something, of course, multiplayer game, online multiplayer game. So what happens is just like provide him with a unique game name, or a room name more particularly, for example, game 1 or room game 1 or whatever, just a unique name, of course. He takes that, he types it in as well, he clicks enter, and you both join to the same room, which means you're gonna both play the same game and join the same room, and you both gonna have like a tic-tac-toe match going on, and then this kind of criteria, if that makes sense. So that's exactly what we want in here. So we're gonna build it this same way, where you have to like, you can enter any custom game room, and of course you can join it, you can manage it, and you can play with the other player. But as we did before, only 2 players can join the same room. Otherwise, it's just like the server is gonna throw an error, say, oh, you can't join this room because it's already full. You got the point I'm trying to say. Pretty sweet. So let's go ahead and just add the logic in here. So for this one, we already have a container in here, so we're going to have a couple of stuff. But for this particular tutorial, because it's not going to be pretty much a lot focused about how to pretty much have CSS styles and how to style them, and since they're going to have like a pretty basic components, a pretty basic CSS styles and CSS and JS components, I will just like copy paste most of my CSS and JS components, most of my style components from like ready-made code in here, just paste it in here, because mostly we don't need any of that. We don't need to go in details about these. This is just gonna be like a waste of time if we do, and we don't want to waste any time. So we're gonna just like have a valuable stuff, and we're gonna learn valuable stuff before jumping anywhere further. Okay, pretty sweet. Now I want to just like go in and replace this with a welcome text. So I can go in and just like completely ditch this off and completely replace it with a welcome text right over there. And we're gonna have a main container in here. Maybe it's gonna have later on something like how we join, and we can input our custom game room. But for now, we can say hey or hola, whatever some sign of stuff like makes sense in here. But there you go. So we got welcome text in here, and this is basically the theme that we're gonna choose. So this is the color theme we're gonna choose, which is kind of like magenta. I love this color, and yeah, I want to just use it for the main theme of the game. So I'm gonna basically build it on top of that. So I can go in and zoom in a little bit. Maybe let's just leave it for now, and later on we can zoom in a little bit as we go further, as we style stuff along the way. All right, pretty sweet. So we got most of that in here working perfectly. The next step we want is actually to create the game context, or the React context. Why we need a context is actually basically because we need to share props between different components, and we don't want to explicitly like pass those props down to those components, down to the child components. What we want is just like say, here's my React context. I just want to provide this state or this store or this props to the down children. So any child will have these props, and you can control the whole state basically. So we can have this application, this main components right here is going to act as like the main components, where it's going to have the state and store all the states and everything. And we can have the pretty much like a context that's going to provide it through this into the children. So let's go and create this real quick over here. So we can then go ahead and create a new file. I can name this game context.typescript. And since we're using pretty much TypeScript in here, so we can use interfaces, we can use like the typing system of TypeScript. So everything powerful and good about TypeScript, we can use it in our advantage day here. So that will be really good. So we can go in and just like input an interface in here, and this will be like the game context props, or you can pretty much think of this as the state. For now, it's gonna be empty, but any state or any props we need, like any states we wanna keep track of, we can just go in and provide the types for it in here on this interface. And the next one in here, we're gonna create the actual default states, because you know any kind of states should have a default state, and that's what's gonna happen right over here. So this one is gonna have the type of the game context props, and since there's nothing, so we can default it this way. And last but not least, I want to go ahead and do it like defaults, export default React dot create context, and I need to make sure we import React, which I did not. So click enter, React's going to be imported, and here we need to just like provide the default state for it and export the context right over here, and everything will be in the place. Pretty simple. That's basically how you create a context on React. So nothing too complicated. Now we can jump back in here and we can actually create the state for the context. So any state we need, whatever, we can just go and put it right over here, and the context is going to make it work perfectly without any problems or issues around the corner from that side. Okay, so let's go back into the socket web for a second, and let's start off by connecting to the socket. And for doing this more particularly, actually we can use something like a little bit kind of like in a good way, in a compositional way, like classes, and uses some dependency injection. Rather than just having all the code inside of this component, we can just like split it over different classes and different components, and we can actually have the advantage of reusing this code and make our app look a little bit more cleaner and easier to read, and of course a little bit more maintainable if you have this application for like a team or developing this application as a freelancer or anything of that sort. Always think this way to make it a little bit more maintainable, easier to read for you as a developer, for the team, or something like this. And most importantly is actually to write a better code and a cleaner code. So that's what we're trying to do right here. And let's go ahead and try to create some service. So for a service, what I love is actually about services is actually create like a folder of services in here. And each service is actually kind of a class that's going to take care of representing, like acting as an entity, which pretty much can go ahead and control or pretty much gets the data and communicate with an API or a socket API or a socket server. So you can just like delegate this handling to a specific class, a specific instance that knows everything about this particular criteria of handling an API, getting data from an API, like the different parameters the API is going to be using, and all sorts of stuff. So you don't have to care about them inside of your React components. So the React components, all it takes care of is pretty much like importing this kind of like class components, initiating it, and using those methods. Pretty simple, right? And this makes it really, really good. So here I want to create a service, and this service I want to name this, for example, let's say we want to like, since we use a couple of different services, I want to create another folder. So for example, it's going to have a socket service, and in this one, I'm going to have an index.typescript. So the index in here means this is the main one. Now we want a class, obviously, so I want to name this socket service. And this socket service is going to basically take care of like managing different sockets, like connecting, disconnecting, handling different standard sockets, kind of like events and those kind of stuff. So that's why we want it right over here. And here I want to make sure go ahead and export default new socket service. And the reason I'm doing this way, the reason I'm exporting a new instance is actually to export only a single instance. And this falls down into the singleton or the single instance pattern, if you're familiar with that, where you just like export a single instance of a class, and every single other module that imports this class inside of it is going to have a single instance initiated throughout all of these. And this is a really good approach. This is a really good pattern to use. So that's what I'm trying to do right over here. Now for the socket service right over here, what we want is more particularly is actually a way to handle the connection. So that's all what we want, and we want to have this as a method. So I want to do public and I have connect method, and this connect method is basically going to be like connecting to a specific socket server. So it takes a URL, it's going to be a string, and this one returns a promise, and this promise is going to be a socket itself. So we're going to go ahead and import this socket from the socket.io client, and by default this one is going to have like a default event map. I'm just like initiating the default one and default events map. So just like using the default one that here is provided as a numeric type over or a template type more specifically. So this connects one is going to like connect and return the socket instance for us. So for doing this, what I want, I also want to hold like an instance of it. So I'm going to have to do public and hold this as a private attribute or a private property inside of the class. So there's going to be a socket or it's going to be null. And for this one, I do like this dot socket. And of course, make sure to initialize this to null. And so this one, I'm going to use the IO, which will be imported. And I can, of course, provide it with the URL. And if you need any kind of other options, you can provide it, but wouldn't need any of that. And what we can have is actually different like events. So we can do socket.on. And for example, on connect. So after connecting and everything, what we can have is actually we can resolve the promise, which means we can go back right over here, do new turn, new promise. So just like we promisify this method over here, and we can just gonna have this one down here. This should make it look good otherwise. And as soon as it connects, so this is gonna act as a promise API. So this connect method waits until this connect callback is called, which means we're gonna have the resolve called in here. So we can have resolve rejects, and we can just have resolve called with this dot socket, which is the socket instance we said that we want to like go ahead and pretty much, of course, like initiate everything with right over there. Okay, that sounds pretty good. And here I can do like if not this dot socket. Basically, we can just go and like return rejects, and like we can do, or like just like rejects, whatever. We don't care about what we rejects with. And yeah, so this says it's not assignable to this default one. Okay, that should make it, that should ignore the whole thing in here, and that should be always good. So we don't need to care about anything that's. So that should be like, as soon as it connects, it's gonna like resolve without promise, and that should be all good. And also I want to handle any kind of like error connection. So if I do socket.on, and there's actually this special kind of like event or error event that is going to be triggered by the server. So if the user attempts to connect, which is the socket client, if it attempts to connect to a server, and if an error happens along the way, there is this connect error event going to be thrown out into the client. So we can go in a listing for it, and if we say, oh, if there is any error, we can of course inform the client that there is this such an error exists, so we cannot connect. So we can, for example, just console log connection error, and we can provide the error, and of course we can reject with the error itself, and that should be all good. So that's just a basic promise API using or promisifying the actual socket API, and that should all make it look good. Okay, pretty sweet. We got it this way. Now we can go ahead back into our application, and actually we can go in and connect to the socket. So we can create a method in here. I can name this connect to socket, and this one should take care of like connecting to the actual socket. So we can have async. We're gonna use async await right over there. That should be pretty perfect. And what I can do is actually gonna have like a socket. You can do this, or sorry, you can have socket service, just gonna be imported for us. I can connect, and I can provide it with the URL, which is localhost 9000, and I can of course have a catch. So if any errors happen along the way, we can just go and console log say error or something. I think it already actually being handled, so there's no issues around that. And here of course make sure to use await, so we are actually waiting for this connection to be made out. Okay, that should be all good. Now we can use effects, and we can go back, and I can of course, as soon as the components mount or as soon as the application mounts, the first thing you need to make sure that you do is actually connect to the socket. Yeah, connect to the server, initiate the connection, and keep a track of it. Now later on, as we need the socket connection, we can obviously access it through this attribute in here, which is going to hold our socket connection instance, because we are always exporting the same instance in here. We are just initiating once, so any kind of other module that imports this one is going to have the same instance over and over again. You can think of this as a singleton or a dependency injection, where it's always going to share the same instance among all the modules that import that particular instance, if that makes sense. Okay, pretty sweet. So going through this, it's actually pretty sweet. And the reason actually I'm going through this like kind of details on how to initiate stuff, instances, classes, is I don't want you to pretty much have socket IO as a bare minimum. I don't want you to put actually a bad socket.io code, because it's very hard to manage socket.io code, and especially when a lot of events kind of erases and all that sort of stuff, it's really hard to keep track of them. So better just like write a cleaner code, better try to write it better first way or first attempt, and you can pretty much learn how to write a better code, especially socket.io or dealing with APIs or those kind of stuff. Okay, so that should be all good, and should be pretty simple pretty much to have it all the way right over here in a pretty simple scenario. Nothing to pretty much worry about or something like that. Alright, pretty sweet. Now the next thing we want is we're going to have another component, and this component is going to take care of, like, you can imagine of this as an input field where you input the game room that you want to join. Of course, as we said before, 2 players can join the same room, so if 2 players input the same game room, they're gonna join that room. So that's what we want, just an input where the user will be able to input the game room that he wants to join into. So for that case, I'm gonna have to create another kind of folder. I'm gonna name this components, and inside of that, I'm gonna have like the join room component, and inside of it will be like the index.typescript. So for this one, what we want is actually to import React from React. So as we always do, and I can go and export a function which is going to access our components. So join room components, it's going to have props, and we need to provide some interface, which we're probably not going to be using anyway, but yeah, always better just keep it there. So I join room props, and here I join room props. That should be all good, and we are actually good to get started with this join room components. Of course, the components, what it does, I said before, just an input field, but we're gonna still need to have some like style components and containers to manage and all sort of stuff. So for that case, as said before, I already have those components laying around there. They already exist from like the style components, so I'm just gonna copy paste those because those are kind of generic, just like an input and a flex container and a custom button, if that makes sense. So I'm just trying to make this pretty. I will walk you through exactly what's going on here. So let me just go and import style here, and that should be all good. So this just a flex container that centers everything to the center with some margin. This one has a height of 30 pixels and 20 EM, which is the room ID input with the actual input, with some border, which is using our magenta theme color. And here's another like a custom made button that matches the magenta theme as well, with some hover effects, and we got some padding to it and font size. Nothing too complicated, nothing worth going through. This is not a CSS class or a CSS tutorial, so I would rather go into like a little bit more better details than just covering all of these in a very long video tutorial, if that makes sense. Okay, pretty sweet. Now it's going to render all of these, and it's going to be the join room container, and inside of that, of course, the join room container is going to be like the main placeholder. I'm going to have like an H4 or something. I can say, for example, enter room ID, let's say, to join the game. Yeah, that should be pretty self-explanatory in this case. Here I'm going to have the room ID input. It's going to need a little bit of parameters, of course, and the join button in here, I can just like name this join. And I think what we can, of course, provide on top in here is actually like a form, just like to wrap everything in a form, if that makes sense. And we can have it all formed out, so you can just like use something like on submit and add keyboard support and all this stuff. So that should be all good already. Now we need to manage actually, let me just add a placeholder, so room ID, for example. And I need to manage actually pretty much like whenever the input changes, we need to update the state and all this sort of stuff. So we can have this as a normal state and this kind of stuff. So we can do, for example, const room name and set room name. So I can do use state, and this one will be like an empty. And of course I can have a different handler, which is kind of like handle room name change, which basically is going to take the event, which is the React change event. And for this one, is going to basically handle whenever the room changes. So we can go in and extract the value of it, and we can say const, yeah, that should be, so e.target.value, and yeah, that should be the actual value. You haven't provided any data, so you can provide any and what we can do is like set room name to the actual value we got. Now for the value indeed in here, we can just like provide it with the room name, and that should make it all good. And of course we need to provide the onChange, which is gonna handle room name change. Okay, that should be pretty simple on how to handle that and everything. So we're actually basically good to go with this room change and everything. So all we need to do is go and integrate that into the main app components. So I can have join room here imported and rendered into the main components. And there you go, we got already the main room, which is centered horizontally and vertically both. And here, whenever you can have an ID, for example, game one or something, click enter, and this should submit. Of course, as soon as we click enter, this is kind of like happening and everything. But yeah, that should be all good from this particular sense of a joining room. Okay, pretty sweet. We got the first thing, or the first step, done. Now, the second one is actually joining the room. Now, what we want is actually whenever we put this kind of room name, room ID kind of unique thing. Now, whenever we click enter, we actually send it using the socket.io, and of course, we send it to our controller, which controls joining a room, and join the actual, or the current user socket, and join it to pretty much the actual room that is specified throughout the input. So that's basically what we want in here. Now, first, we need to go to the game context, and we need to provide some context, something like is in room or not. And we need to provide some state, something like is in room, which is going to be a boolean. And we need, of course, the set method, so set in room, which is going to be like in room. So it's going to take a boolean as an argument and returns void. And for the default state in here, of course, by default, it's not in room unless it joins the room. So this is like an empty method, and so it just like does nothing. And this is the default state. Now, inside of the app.typescript, here we need to provide the actual state. So we need to like create the actual state and provide it throughout to the context for this to work. And we haven't provided the context yet, so that's what we're going to be trying to do right over here. So first, I'm going to do is in room, which just like using hooks, of course, and set in room. So I'm going to do use state, and of course, I'm going to provide this as false. Now, the second thing I want is actually to provide something like game context value, which gonna have game context props. All right, so it's gonna have is in room and sets in room. So both in here are inside of this context value. Now we need to actually use the game context provider. So we need to do like game context. So it's game context, I think. It's imported or not. Let me just gonna try to go a couple case, because React components needs to be like this way. And of course you can use the dot provider and wrap the whole children, the whole React tree, everything in here inside of the join room, everything inside of it is going to be like have access to these values throughout the context. And of course we need to provide the value, which is the game context value. Sweet, pretty simple, pretty easy. I think that you should already be familiar with how React context pretty much works. Just like a small minimal Redux store, if you're familiar with that. All right. So let's go back to the join room here. So we can go back to the join room, and here through the join room, we can go in and like access these. So we can, for example, set in room, and we can access is in room, both. So we can do use context, and we can access the game context. And this one, we have both the set in room and is in room, both of the state variables. We can have it right over here. Now, whenever we need to control that, we can basically have it all working this way. Now, for controlling this, what I want to do is I go in and create a new join room method. So this method, what it takes care of, this will be an asynchronous method. So this one, what it does, it basically uses a socket instance. It sends the server a request, say, oh, here's the new room ID, and this is what I want to join. Okay, I want to play with my friend, which is living in Australia or across the country or across the whole world, whatever. But that's the point. Now, before jumping anywhere further in here, we need to basically have another service that takes care of sending of that. As I said before, server is going to take care of like connecting to socket and handling everything, so we don't have to worry about these inside of our components, if that makes sense. So I don't want to use this same socket. I want to create a brand new socket. And this one is going to be like the game service socket, which takes care of anything related to a game, like joining a room, sending game updates, closing a room, saying you're a winner, anything of that sort, basically. So for this one, what I want is actually game service, and I have like an index.typescript. And as we did before, we can have a class game service, and we can export defaults, single instance, game service. Okay, and this one in here, we can have like another method which takes care of like joining a room. So we can name this like join game room or something. And here we can provide it with the actual socket, because we need the socket connection, otherwise we won't be able to work without it. And we need the room ID that the user is intended to join to. And of course, it can have a promise, and for example, just a boolean saying or indicating that we have joined the room. So if it's true, we have joined the room. If it's false, we haven't joined the room, just to knowing if it is or not. Okay, so here we need to return a new promise, because the whole point is promise define everything. Resolve and reject, and we can have all basically in a single spot. Now, using the socket instance, we can go in and emit. And remember, if we go back to our server, we got the events that is being listed on the server is the join game event, in which it's going to take care of everything that pretty much what we need to join a room. All right, so we can have the logics here. So we can do like join game, which is the name of the events we want to like emit. And throughout this one, what we want to give them is actually the object, because it's pretty much expecting through the message a room ID that the user is wanting to join, so you can provide it with that one throughout the socket.emit. Now, before any resolving the promise, before letting the user, oh, he has joined, if you see right over here as we did it, it just like on a success, it says room joined, or an error says room join error. So we need to listen for both of these and decide whether or not it is an issue or the room has been joined successfully by the user. So if we do like room joined, okay, that's pretty great. All we have to do like do like resolve with a true, saying, oh yeah, it has been joined. And else, if it's room join error, which is so here, so we can immediately go ahead and reject that with the error. And of course, here we get the error back from the server. So we get it on the response, and we just like immediately pass this error, and it's going to be just like a string. And of course, we're going to like show it to the user as an alert or something. And you can say, oh, you can't join to the room. There's that blah, blah, blah kind of issue. Maybe it's the room is full or something like that sort. All right, so let's go back into the join room logics in here. And of course, we can take care of like the logic of how join a room and everything. Now, here first, we need to go ahead and grab the socket through the socket service dot socket, and this should get us the socket and everything. The next one in here, we need to make sure that if the room name is not valid or something, so we need to do like if not room name or the room name dot trim, which could be like just an empty room name equals an empty string, or not socket. We're just gonna immediately return, which we're not gonna like do any submit, we're not gonna join in a room or something like that. The other thing in that here we need to take care of, like if the room is joining, because sometimes the user takes if the server is like overloaded or there's tons of people are joining, so we need to keep track of it's currently joining or not. So for that, we can have like is joining and set joining. I hope I'm spelling that right. Okay, so use state, and we can have just like set joining to true. Now after setting that, we can go ahead and actually join. So we say if joined equals await, and we can have like the game service, and we say join room, and we just like provide them with the actual socket we got and their room name or the room ID. Of course, you can catch this if it has any errors or something that comes across, and we're gonna immediately go and use the alert API just to simplify the process in here, just like alert it to the user. Of course, you can have a much better way in here because it's a game, so you need to make sure everything looking pretty, everything looking like more customized in a gamey kind of themey thingy. So that makes sense. I hope it does. Now if it's joined, which means it is true, now we say go ahead and set in room equals true, which is, you know, the most basic part. Say, oh, we joined the room, so we can start playing the game. And through this context, we can actually start playing the game. Now set is joining, we're gonna set it immediately to false because it joined and everything, so we can completely get rid of all of these. We don't need that anymore, so we can completely just go in and dish that off, and we don't care about this one. Okay, so that should be all good. So joining a room should be as simple as that. Nothing too complicated, nothing too hard or something, and we should just get it like this way. Now on the button here, we can have a type, which is going to be the submit type, and this should be the submit function. So you can take an E, which is React dot, I think it has a submit, or okay, so React, I think it's an event or a form event from that source. So you can go and do like e.prevent default, just to prevent the default behavior of the particular room or the form. And here on submit, we can just go and do like join room. Okay, that should be good. And we can go in and save that. And we're pretty much good to go from this sort. The other thing that we want to do is actually go ahead and handle the state of joining or not joining. So I want to make sure, like, go ahead and disable that button if it is currently joining, so you don't click it multiple times. And for this section here, so if joining, like if the user is currently joining, we can have like join in with multiple dots or many dots. Otherwise, just like show him join, if that makes sense. And yeah, that should make the logic look really good, and that should make it look really perfect from that particular sense. So if you go ahead and join the room, remember right now the server doesn't have anything. It doesn't have any room joining, any new user. It doesn't have that. So if you go back, for example, we can have game one, click enter, and if we see, there you go, we got new user join in, and this is the room ID we provided, and that's actually working. And if you see, actually the state is being changing so fast, like we get the join in and everything, but here we got like room is full, please choose another room. Why that's happening? If we go back to the logic real quick, we're gonna just actually do like socket room. So if socket rooms is more than 0, that means the current socket is already connected to another room. So he can't pretty much connect and initiate or join more than one room. That's the basic logic we're doing it. That's why we're throwing an error, and that's why we're preventing it from joining another room. And that's a pretty great actually handling system. That's pretty great precondition and all this sort of stuff. That's looking absolutely amazing, and it works as charming as it would look like. So that's kind of perfect from that particular sense. Pretty sweet, right? Okay, pretty sweet. Now we got the first logic working perfectly. We got the room joining, and we are indeed setting like is in room. So throughout this variable, throughout this boolean, we can tell if the user is already in room or not. So if he's in room, we can start the game, and that's the whole point of joining the room and just like making sure and handling all of that state. So let's go have another component. I'm gonna name this component the actual game, like just game. And I'm going to name this like index.typescript. So this will be like the main components of our game, of our tic-tac-toe game, where all the logic is going to reside, where everything is going to happen, the whole magic. So I'm going to have props, and this is going to be game and interface. We're probably not going to be need that, so I don't care about putting that anywhere. So that's basically the game, and that's how it should look like. For basically the game right here, there's tons of variables, there's tons of like style components that need to go through, and we just basically gonna paste those. I'm gonna just like go through them and try to explain each one and how I put those right over here. Of course, there's many scenarios that you can go through to have a tic-tac-toe game, to create the board, you know, those scenarios throughout CSS, always a million way to do it. But just like this is just my favorite way to go through this. So I'm just going to copy all the style components, all the CSS in here, and I'm just going to paste it on top in here. Okay. And of course, make sure to go ahead and import styled. We don't care about this width and height. Anyway, so yeah, we got everything being put really well on top of here. Now we got here first the main container, which is just like the game container using some kind of like awesome fonts that is being loaded on the index.css, which is like the Zen Tokyo Zoo. You will see that font in a second. It just like looks really good. I just like try to use this just to make it modern. It uses flex and a column in here, and there's this row container, which is just a row container, just a flex row container. Now for the cell, what a cell means is just like a single cell. If you're familiar with Tic-Tac-Toe, it has like it's just basically a matrix. It is a 3x3 matrix, which has 9 cells in total. So each cell in here is going to be like represented by this container, this particular component. And I'm having just like this props in here passed in, so we can pass in these props or this particular props to the component to render the border. So if the border top is chosen, we're gonna render the border in this magenta color, and we're gonna just like, depending on that, we render these borders of top, left, bottom, right. You got the point of what I'm trying to do. There's some hover effects into it, just like clicking, and some flex containers and some pointers and stuff like that. Something pretty simple. So for this another container play stopper, so here we just like to stop the play. So if it's turn for the other player to play, so we don't want both players to have their turns of just clicking around and having a panic attack throughout the board. We don't want to do that. So we want to stop when once the other players he's actually playing. So to stop that, just like draw a container on top of it with a position absolute. So once he clicks or uses the mouse, he can't click anything. He can't reach the board with the Z index 99. So that's the highest particular container over the cell here. So that's not going to be able to click it. So that should be good. And basically with this, the X and O is going to represent the actual X and O of the tic-tac-toe. So just a font size and magenta color. I'm using the after in here just to put the actual value of X or O, if that makes sense. I'm just like trying to put it in single components without like having it all the way around that corner. And yeah, that's basically all you need to do for that particular sense. And that's basically all you have to make it work in this particular scenario. So that should look really good. And that should basically work from a single perspective of how stuff should be looking like. Okay, so that should be pretty simple. Now let's go ahead and get started. Actually put the logic of rendering the board. Now first thing in here, we want to hold out the actual matrix, the game matrix or the play matrix, whatever you want to call it. So I want to hold out the matrix in here in the state. I'm going to have matrix and set matrix. I'm going to use state. And the matrix is of course an array of arrays. So it's like a big gigantic array of 3 different arrays. So it's a 3x3 array, if that makes sense. It's a 3x3 matrix. So this one, I'm going to have 1, 2, and 3. So each one of these arrays is going to represent a row. Yeah, so if that makes sense, it's a row. So 3 rows in here, and each value inside of these rows or inside of these arrays is going to represent a single column. So I'm going to have null because they don't have anything yet, and initially they start all empty. So we're going to have like null here, null there, null everywhere. So that's all nulls. It doesn't matter. So just like a 3x3 matrix said before, and we can go ahead and use some logic to basically render this matrix automatically. So I don't want to go like render this like manually, or I'm gonna like explicitly. I want to have it an implicit rendering using some kind of like algorithm, which we likely do have a simple approach to do that. So first we need to make sure to render the game container, which is the main container that we're gonna be needing and everything. Next we need to use the matrix, and we need to map through this, and we can have different stuff. So first we have the row, and I'm gonna also have the row index. So edx in here, and what's going to be returning here, I'm going to just like return the row container. And the reason I'm returning a row container, because as I said before, each array, each sub array right over here is going to represent itself a row. So we want to render a new row, a new line, and all the columns are going to be like on the same line, which is those 3 nulls going to represent, each one of them is going to represent a column, if that makes sense. So I'm going to go inside of that. So I'm going to use the row. I'm going to use map again. I'm going to have a column. Then I'm going to have a column edx, or an index for that. And last but not least, what we're going to be rendering is the actual cell. So I'm going to use the cell in here, and that's it. That's basically all you need. But there's still some stuff needs to be made out, like to play around with the border in order to make sure that you render the border right. So in this case in here, to render the border right, what we want is actually to, use some indices like the row index and the column index to determine if to render the border or to completely ditch the border and not, completely ignore the border and do not render it. Just to form the whole board and the whole board border, and to make it look like a tic-tac-toe or like a matrix, like a crossed lines matrix tic-tac-toe board, if that makes sense. So for this one, we can have, for example, border right. Border right has some relation with a column index, so we can have only render that if a column index is less than 2. Otherwise, just completely ditch that out. And remember, the column index is from 0 to 2, like 0, 1, 2, because there are 3 columns. And the row index as well, 0, 1, 2, 3 rows. Simple. Now the next one is actually the border left. Now for the border left, we want to also the column index, and we want to make sure the column index is greater than 0. So completely ignore 0, but go over 0, and you should render that. The other one is the border bottom. Now we can use the row index because border on tops are, covered, or I don't know how to say that, but I will say covered or bordered by the rows, the top and the bottom, if that makes sense. So if it's greater than 0 or greater than, less than 2, make sure you can go ahead and render that with a border. And last but not least, for the border top, so use the row index and only render it if it's greater than 0. So if it's greater than 0, go ahead and render the hell out of it. And if it's not, just completely ignore that and don't render anything. If that makes sense. Okay, so that should be good. But the cell in here, what it needs either X or O or null, nothing. So to determine that, likely we got the value in here. So if it's null, we're not going to render anything. We're just going to keep it empty. If it's X like this, so if it's X, we're going to render X. If it's O, we're going to render O. Otherwise, if it's null, or even if it's null like this with a string, we're going to render null. We don't care about that. But only if it's X or O, we're going to render that respectively using the components we got on top right over there. So for this case in here, we can just use some douchey way to do it. So we can do if column and column not equals to null. So just checking for the string version just to make sure of it. And if that, so if column equals X in this particular scenario, so what we want to render is the actual X component. Okay, so render the X component. Otherwise, we want to render the O components, if that makes sense. Otherwise, we want to render null. So how that actually, it might seem a little bit kind of confusing, but it's pretty simple. So if it's column, or if it's not column, we're going to render directly null. If it's column and column not equals to null, and we're going to check the column value. So if it's equal to X, we're going to just render X. Otherwise, it should be equal to O, right? We're going to render O immediately. And this null is actually related to the first parameter in here. So if it's not column, we're going to just render null, which is going to show an empty cell. That makes sense. Okay, pretty sweet. So that's basic logic that we need to basically render the whole thing here and there, and just to make sure that's basically working. So let's go and test this out and see how that works. So if we go to app.typescript, and for this one here, what we're going to be checking for is we're going to render the join room if not is in room. So otherwise, if is in room, so I'm going to do that, and I'm going to render the game. I'm going to import it and render the game. So once we join, we should see the game board popping on us. As you can see, the board is already here because we already joined. But here, since we refresh the application, we get nothing. I don't need to remove that. But as you can see, refreshing that, we get nothing. For example, we enter game 1, we join that, and hallelujah, we already got our game board actually coming on top of us, and seriously it looks pretty amazing with these borders, and it just like makes it really look like kind of like retroactive and kind of like classic board with those borders, because they match really well because we added some border radius to it. So that's why you see this kind of like really cool like bordered radius, those kind of like shapes and those kind of like triangles. They look absolutely amazing. Completely love that. So yeah, seriously, we got the board rendered for us. And if for some reason, if you go back to the game, and let's say here in the middle, I want to have like an X or something, and you go and try that, as you can see, the X is in there indeed. And if I have like game, there you go, we got the X in the middle there, and that's actually working pretty much fine. So that's all working, and we can have it basically they working this way. So that's pretty sweet, right? Having all of these ways to pretty much render that with this kind of algorithm, so you can put whatever you want to put inside of it, and that should work right on top of the corner. Now, what we want is actually whenever the user selects a cell, like clicks on the actual cell, we want to update that cell with a symbol that is selected for that particular user, if that makes sense. So what we want, basically have a method, and I'm gonna just like name this update game matrix, and this should take care of like we can have like column, which is going to be a number, and we can have a row, which is going to be the number, like the column and the row that we want to put that on, and the actual symbol, and the symbol is just basically either X or O. So this is going to be X or O, and of course no or null cannot exist because he needs to put something, he needs to have something. I don't know, we need to make sure like we need to create a new matrix, which is I'm gonna like extend the old matrix we got, like the current matrix. So just like create a new instance of it, and I'm gonna just go in and check if it's null, like just do a double checking in here. So if new matrix with row and column, so if it is this and equals to null, or basically, since we check for strings as well, so if it equals to null string, it's like a string version of null. So only this way, or only in this particular case, update it, because if it's X or O, do not update the board, and it violates the whole game kind of laws and everything. So we need to make sure that only once it's null, we update the game, or we update the matrix. So we do new matrix, row, column, and this should at least equal the symbol of the current user, if that makes sense. So I should make it pretty simple this way, and I need to just like wrap this through using an if statement. Now yeah, so that should be not assignable to type, is not assignable to type null. Really unsure why is null. So that should be actually a null, because a game matrix should be simply different than that. So it should be a little bit more different than this way. So what we can go ahead and have a different type. I don't need const. I need just like to declare a custom TypeScript type more particularly. I'm going to export this one. Indeed, I'm going to use a type. I'm going to name this play matrix. And this play matrix is going to be like an array. So it's going to be just like a type definition of an array of a string, if that makes sense. So just like it could be a string or null, because there's a case where it could be a null. And also we can have another one, which is like an interface, and it can be like well, let's ditch this off for now. We can have this a little bit later on once we cover this one. So here we can just go and use this play matrix, and that should already make the error go away. Now we need to update the actual matrix, which is going to update it with a new matrix. Okay, now for update a matrix, when this happens is on click. So on click, and we're going to have a new method. We're going to do update game matrix, and we need to pass in the, I believe the first one is the column, right? So we need to pass in column index and row index and the player symbol. And for the player symbol in here, we need to know like what's the player symbol, like what's the actual player symbol or something like that we need to make sure that it takes care of and be able to have this way. So for the player symbol, what you can do is actually store it on a variable, and more particularly like on a global variable. Then we can of course update it. So we can go back to the context, and we can go right over here on the actual game context or something. And for the game context, anyone would have just like a symbol is going to represent a single string. So we can have, let's name this player symbol maybe, and that should be a string, or that most likely should be an X or O, right? And we can have set player symbol, which is going to be symbol X or O, and it's going to have a void. Now here we can have player symbol. Let's say we're going to default this to X, and set player symbol. So this should default to an empty method. So we can go back to the open here again, and we can provide another state. So player symbol, set player symbol. We can use states, and we can make sure like this start with an X by default or something. And here we can have like player symbol and set player symbol. Okay, okay, that should be a type of like X or O. Okay, that should make the error go away, and we're actually good to go with that. Now we can go and grab the like player symbol from the top in here, so we can do player symbol, set player symbol. We can actually use context, and we can pass in the game context indeed. So there you go. So we got the player symbol, and we simply here need to pass in the actual player symbol that we want the player to play with, and that should basically update the actual kind of like board. So if you join a room, we click on this, there you go, we got the X everywhere, because the defaults to X basically. If you don't change it, you're always going to default to X. And there you go, you got your board, and you got this being fulfilled for you. So whenever you click on a single cell, that's going to be fulfilled. And of course, if you click this, it's not going to be updated, because we're checking only when it's null, update that. And that makes sense, and that's basically working as charming as it would be. Now, the logic behind the scenes for this case is actually to update the game matrix. Currently, we're only updating it locally, which means we're updating our current state. But if the other player, that since we want like a multiplayer online game, so we want to send this updated matrix over the network to the other player and update the other player's state with that, like update the other player matrix basically, and just like say, oh, that's your opponent, that's what he's made his move, he put an X in here, so it's your turn, go ahead and play, if that makes sense. So that's exactly what we want to do. And of course, we need to use the socket.io. We send it to the server, and the server is going to send it to the other connected end of the room, and of course it's going to be all connected together, and it's going to be working as charming as possibly would be. So let's go ahead and have this controller first on the server. So for this one, I'm going to create a game controller, and I'm going to go game control.typescript, and this is basically going to be a normal controller. I'm just going to copy paste this. I don't want to just like have it, you know, from scratch. I don't need most of these basically. So I'm just gonna keep the same thing in here. And this one is of course gonna be like update game status or something. And this should be like update game as well, which is like a controller just to update the game. Of course, we're gonna accept a matrix throughout the message that's going to be provided, and throughout this matrix, of course, we're going to like send it to the other connected users of the room. But first, what we need is actually to have some like a private method, and this method, what it takes is actually you give it a socket or you give it a room, and it gives you the other connected client to the room, so you can send it to him. Or basically, if you got like a socket, what you get is actually get the socket's room that is currently connected and joined into, so you can grab the room and send basically whatever data you want to whoever is actually in the room. And of course, since your logic is actually only controlling to be having two players or two sockets or two clients on the room only, can't be more than that. So you're going to be only sending it to another client, because once you broadcast from a single socket, the current or the socket whom sends the actual or emitted the actual message, it's not going to be receiving that message, because it's going to go to everybody else's on the room but the one who sends the original message, if that makes sense. So here what I'm going to do is actually get socket game room, and for this one, what it's going to be taking, I'm going to basically just like provide it with the actual socket that we want to get the room with, and of course it's going to return a string which is like the room name that this socket actually belongs into. So we're going to have like socket rooms, and initially a socket has many rooms, so like by default for socket IO, any socket that is joined to another room, by default it has a default room which is its own room. That's the room is denoted by its socket ID. So it just like in a room, private room exists to itself, and it's denoted by the socket's unique ID. That's it. So there are two rooms in our case. There is the room that we joined, which is the game room, and there is the sockets room, the default sockets room. So what we want is actually filter and remove the sockets default room and only leave our game room that we want to get. So that's the point in here. So I'm going to use array.from in here, which converts an iterable to basically an array. So I'm going to use socket.rooms, which is going to give me all the rooms of the current socket. I'm going to use values in here, which is going to give me all the values. And of course, I'm going to filter that, as I said before. So I'm going to use the filter, and here for the filtering, I want to remove, as I said before, the socket's default room, which is just like denoted by its ID. So I'm going to like do a filter in here if R, which is the room name, not equals to the socket ID. So I'm just going to like remove the socket ID from the arrays list, and that's basically what I'm doing in here. And here I'm going to have like game room. So to get the game room, all you have to do is actually make sure you got sockets, which are valid, and you access the first one. Pretty simple, right? And that's going to give us the first or the actual game room that this socket is actually joined into. And last but not least, we can just go and have game room. Of course, what you can do in here is actually check if the array is empty. That means the socket is not connected to any room, which means the socket cannot update the game, so you can prevent that. Of course, it all goes to the game prevention logics and all sort of stuff. I'm not going to go into these details. I'm just going to show you the bare minimum stuff, because building an actual game is kind of hard, and you have to go through a lot of scenarios you need to cover. So that makes sense for you guys, hopefully. Now we're going to have the game room here. We're going to like return it and everything. So we can go ahead and use that. So I can do like game room. I'm going to use this. .get socket room. I'm going to get the socket room here, and basically I'm going to use socket.to, and the to method in here it takes actually targets a room when broadcasting, and it's going to broadcast to any other socket connected to the room, as I said before, but the one sent it. So this socket, the current client that has sent the actual message, won't receive the actual message itself. So it won't duplicate the message and send it back to him. No, it only send it to the others who hasn't got the message yet. So here I'm going to like use the game room. I'm going to emit, and for the message in here I'm going to emit is actually on game update. Okay, and on game update, and I'm going to provide it with the actual message the same way I've received it. I'm just going to like forward it back to whomever gave me that. So I'm just going to like forward it down to those guys. Okay, so let's go back in here and let's go into our service. And through the service, we can go ahead and actually use that, and we actually make sure that we update the game every single time that there's an update or something. We just like send it, and we listen for this particular update. So we can have a public async, and we can do, for example, update game, and this one is going to take socket, and of course it's going to take the game matrix. And if this is going to be a type of a play matrix, I'm going to import this from the components game. For this one, what it's going to return is actually a promise. So we can make this a boolean. I guess that will make sense as a boolean or something. That should make it look good. So I'm going to return a new promise. Or basically, let's go ahead and ditch the promise, because we don't need a promise, because that's only going to be sent out. So we don't need any kind of promise or something. And all that's going to happen is actually going to do a socket.emit. And I believe I remember that. It's update game. Okay. And here we're gonna actually send the actual matrix. So I'm gonna name this, I'm gonna like name it to matrix and send it over there. And that should be pretty much it for sending the game. And also we need another method, and this particular method we takes is actually gonna be playing a role of a listener that listens for the update. So as we did before here, as soon as we have this one, we do get the room and we send it back. So the other end, the other player is gonna be listening for any on-game update message in here. So if this message is going to be received, we need to listen for it and we need to react whenever we receive that message. So we update our local state. So both the players are going to have the same matrix as soon as one party updates the matrix or do its move or play its turn, if that makes sense. So in this one, I'm going to name this on-game update. And this basically going to take the socket as always, and it's going to take a listener. So for this listener, is going to be like a listener is going to be a method or a function that takes a matrix, which is a kind of like iPlay matrix, and is going to return void. This is like the type definition of it, basically. So here we're going to have on game update, and simply we're going to just like pass in the listener to it, and the listener is going to be running, and it's going to have the matrix inside of it, and that should basically work fine for that. But I think the listener here, what we actually pass in, since we were passing a matrix inside of that, so what we can do is actually have matrix, and we can like do return listener, and we can pass in the matrix directly into it. So just like destructing the matrix and pass it into the actual callback, and that should all work fine. Really perfectly. So no issues in here. We got the listener, both the emitter and the listener actually happening there. So let's go back into our game logic, and we can use this game service. So we can do game service, and we can do not on game update. We can do update the game, and we can do socket service dot socket. And yeah, we need to also like only do that if socket dot service dot socket is valid. Otherwise, you can't update the game. You can throw a message or something. And I believe here what we need to pass in is the new matrix, like the new game matrix, and just pass it through the network, and that should work fine. Now we also, on the other party, because you're always going to be working like an application, and always you imagine yourself working on both parties. One is the sender, the one that did the updates of the matrix, and the other guy was like receiving the updates, just like waiting for the other opponent to play, to do his move. So he needs to receive that matrix and update the local state with it, so he saves the changes and saves that visually on the browser. So for that, we need to actually register this kind of like game event or something. We need to register it perfectly, otherwise it won't work for us. So we need to go perfectly into this, like register it and use the use effects and those kind of stuff to handle that properly. Okay, so let's go and have this like handle. Let's go like handle game update. And so for this one, we can go ahead and use if socket.service. So just like always check everything. Of course, you can find a better way to handle that, but that doesn't really matter that much. And do on game update, passing in the socket, and we're gonna have the actual listener in here. We're just gonna have the new matrix for us, ready made, and this should be the socket service. I don't know why I don't have that. And as soon as we get that, what we need to do is actually do set matrix, and we can just go ahead and have to set the matrix of the new matrix. That makes sense. Okay, now use effects. And here, as soon as the component mounts, we need to go ahead and call this one. So this one should handle and register this callback whenever this event happens. The callback is going to happen, and this should work. Now, if we go back here and test both of these, the server should be saved. So let me just go ahead and resave it just to make sure that this works. And if I go back right over here, and it can have two instances, I can have another localhost 3000 running. Now, let's try to join both of these instances. Remember, each one of these is a separate instance. They don't belong to each other. So security here is completely different. Now, if I join the first one here, the game, I join the second one to the same room, of course. And for example, the second one, let me just go ahead and click. See here, it's currently empty. If we go back, let's go right into the corner. If you take a look on it, hallelujah, that didn't update. If we update it from this side, if we go back here, there you go, that's updated too. And that's all working asynchronously. That's working perfect. Now, the second thing, or the two last thing we need to think about is basically how to handle turns between players. So as clear in here, we can have as many X's as we want, while the other player can have nothing, which is pretty bad. Now, what we want is actually whenever one player, like one session or one socket, clicks in here, which does it the move, like play a turn, we're gonna stop it, like just like show a container, like play the stopper. We're gonna stop him from clicking, and we're gonna give the turn to the next user to play its move. And once the other user plays, we can go back and forth. We're gonna allow the first one to play and you know, go so far back and forth till the game is finished, so we can check if it's win, a tie, or something from that sort. So that's basically the part that we want to have in here, and we can have it basically in a really good way. So we can check if it's player's turn or not, and we can just like hold this particular state. And basically for this state, we don't need the state to exist on the context itself, but we can go ahead and have it on the context. So we can have like is player turn. So this is just a boolean, and we can set player turn. So we can have turn boolean. This should be a void one as a return, of course. And we can have is player turn false, set player turn, and this should be an empty method. Sweet. So if we go back here, we can hold this one. So is player turn set player turn. Use states, this should be false, and okay, so we got both of these now passed through. Now instead of the game in here, we can have access to this. So set player turn is player turn, so we can both have access to that. And through the player turn here, what we want to do is actually, if it's not the player's turn, so just like on top of all the components, we want to like render out the stopper. Remember this component stopper, which is gonna stop any clicks or something, just gonna be like a big gigantic container on top of the whole board, which means if we render this one, it's gonna prevent any clicking goes through this cell component. So that's the point what we're gonna go ahead and do right over here. So for this one, if I'm gonna check like if not is player turn, so if it's not his turn, whatever, so we can go ahead and render the player stopper or something, and we make sure we go ahead and render that on top there. Now effectively none's player's is turn because we're not handling that properly. Now to make sure that we handle that properly is actually we can go ahead and like as soon as there's a game update, we can change the player's turn. So I can go, for example, where's the game update? So it's clear as soon as we update the matrix, we can do like set player turn, and we can set it to true, but initially it's gonna be false, right? Because that's how it works right now. It's gonna be false. Now we need some little bit of kind of like logic. On the start of a game, we set the turn or set the turn of the current player and handle a couple of other stuff. So we need like a specific handler for telling that, oh, the game has been started. So as soon as like another player, remember, like imagine a single player has joined the room, which means only a single player is in the room. So it needs another player to join the room in order to start the game, right? So for this particular case scenario, the other player is just like sitting down. He can't play by itself. So he needs to wait for his friend to join the same room using the same unique room ID. So what we want to check for, we want to like listen for as soon as another player like joins the room. So there are two players in the room right now. So we can emit like a specific event, say, oh, game is started. And we can randomly give one player the first turn because one player has to start first. So we give him randomly, oh, you got the first turn, you can go first, and you can give him like a symbol that you choose for him, like a random symbol. You can start like X or O, depending on that. Of course, it goes all about the game scenario that you want, of course, but it all depends on the scenario that you want to cover, okay? So let's go ahead into the server, and we can have some modifications to the room controller in here to make sure that we send a specific event telling him, oh, the game has been started as soon as there's 2 players joined the same room. Okay, so let's go ahead and have this in here just beneath when room joined, so we can have like a specific message. So we can check if io dot, for example, sockets dot adapter. So here the adapter here, as we used before, just like get the rooms. So we check rooms, then we can get room.message.room ID. So we just basically getting the room, and of course we want to check the size. So if the size is 2, which means there are 2 sockets or 2 players respectively have joined the room. So if it is the case, what I want to do is go and emit a specific event, which is going to be called like start game. And this event, okay, let me just back here. So this event more particularly is going to start the game, and we can pass in a payload. For example, start true, and this one is going to tell this particular socket, because this is the socket is going to receive this event. So this particular socket is going to receive start true, which means you start with this one, is going to receive this symbol, like symbol. So symbol is going to equal to X, just like a random one. So as soon as this socket joins, it's going to have this one. Else, so what we can do, or basically, yeah, we don't need an else in here. So we can have, like, let me just have this covered here. So just like all inside of that. So this is going to be sending it to a single socket. Only the last socket who has been joined in here, it's going to receive this particular event. It's going to receive start to true. So the last socket who joins the room is going to start the game first. It's going to have a symbol of X. And also we want to make sure we send this event to the first socket, because there's 2 sockets. We're going to send this event to it. So we can do socket.to, and here we're going to broadcast this. I'm going to use message.room ID. And remember, once the socket sends a message to the room, that particular socket itself is not going to receive that message. It's going to be broadcasted to everybody else's but this one, if that makes sense. So I'm going to say, I'm going to send this to the room, and I'm going to emit start game. And the start game in here is going to have start equals to false, because we already gave the start flag to the first socket over there. And the symbol, of course, since the first one has an X, this should have an O, and that should be all good to go. Pretty sweet. That should be a pretty simple logic. Now we can go back in here, and of course we can handle the logic using, of course, like a handler for like listening, as we did before, just to listen for any socket updates or start game updates or that sort of stuff. So we can go back for the game service, and I can go back down here. I can have a public async, and of course on start game or something, we can pretty much have a listener for that particular one. So we can have socket as we did before, and for this case we can have another one, which is the listener, and this should be a listener for like how the start of the game. So it can have some like, you know, options, and this should be void. So I guess we can have some options being put into it. So I think we can go to the room, the game room in here. So we can define an interface and export it. So export iPlay or iStart game, and yeah, I don't need this equal one. So start is going to be a boolean, and the symbol that we start with is going to be either X or O. Okay, pretty simple stuff. Now we can go and like import this one, iStart game, and this should have the void one. So this on start game. And all we want to do is actually socket.on and listen for the start game, and we just like provide the listener, because the listener already takes this options objects, and we already provided it with this objects, which is basically the same object. So yeah, there's no worries about that particular part, and it should all work the same way as it did before, and it should just like handle it properly. So if we go back to the game component right over there, and we can go to and create another handler. So we can have handle game start, this one. So we check if socket service dot socket, copy this one, and I'm going to use the game service dot on start game. I'm going to pass in the socket, and I'm going to have like options, And here, I'm gonna start the actual game. So for starting a game, what we do is you're gonna set some flag that's saying, oh, the game has been started, so you can start playing. Also, I wanna set the player symbol to whatever the symbol is actually being put. And also, if the options.start, that's gonna indicate whose turn it is. Of course, who starts the game first? Who starts with the first turn, if that makes sense. So if it's start equal to true, what I want to put is actually set player turn, turn, I'm going to make it equal to true. Otherwise, if it's false, I'm going to set the player turn to false. Just to be safe, that's what I'm trying to do in here. Of course, we need another one in here, is actually is game started. So is game started, it's going to be a boolean and set game started boolean and a void, and is game started here is going to be false by default. Set game started, again, an empty method. Nothing too hard about that part. That should be all good from this particular side. And so we go here, provide some state to this. So is game started and set game started. So you can use the state set false. By default, it's not started, of course. And you can provide this here, set game started, and we can have it all working the best way possible from that side. So that's good. That's looking pretty good. Now let me just go and import those. Set game started is game started, and I can go back right over here and I can do set game started equals to true. Sweet, pretty simple. Now the last thing what we want to do is actually, after we put in the play stopper, we want to also, if not is game started, or, so we want to, or the player hasn't got the turn yet, so just like do the player stopper. And also what I want to do is actually have another one, which is if is not game started. So what I want to show is actually like kind of like a message showing or telling the user waiting for another player, waiting for other opponents to join the room to start the game. So you can have, for example, like an H2, maybe like this. So you can do like waiting for other player to join to start the game or something. I don't know. You can figure out a better message from that side. But that should be all good. And last but not least, in here we need to handle the game start. And as soon as this actually works, it should be actually working absolutely fine. So let's go and test how that does. I'm gonna refresh both of these parts. I'm gonna join first in here. I'm expecting this to have O. So it's curious, we already get this waiting for other player to join to start the game. And we're gonna have like this one join to the same room. So as soon as this one joins, as clear as the message is gone because they are both joined and the game is started. And as clear as this particular instance cannot click. And to better show that, I think I can have those. I don't know if I can have those side by side. So let me just, I think I could. Where is that? Okay, so I can have this from side here, and I can, where is that? There you go. So both of them sides, clearly it cannot click in here because the play stopper, because this is player's turn first. So let's say he clicks, this one should be having an X, clicks in here, clearly immediately appears in here. Now, yeah, I shouldn't be able to click on that mainly. I don't know why I'm clicking on this, actually, to be honest. But I should not be able to click on this. So if option.start and we got handle game update, and here as soon as we receive that, and of course what I want to also do is actually whenever we do our move and send this to the game, I also want to like make sure I change the game update or change the player's turn to false so he can't play anyway. Let me just go back to both. I can refresh, access the same game rooms again. Now this one starts with an X. Clearly he cannot click anywhere, but it's this one's turn. So he clicks now. It's clearly got O. this one got the O. Now you can choose the X. For example, this one chooses the O, and this one chooses the X. This should have 1, right? So we should have shown him like a message, and we should have checked if the game is a tie, or like one opponent or one player has 1 or not. So you can do this logic real quickly in here. I know XO kind of like, or tic-tac-toe kind of like logic for checking who's won is a little bit tricky, so you need to go through a lot of code. But for this one, it should be pretty simple. Just go ahead and check in for this kind of scenario in here. So let me just so yeah, I don't care about this one anymore. So we can go ahead and have a function. Just go ahead and double check if one player, or if the matrix is a tie, or one player has 1 or not. So that should make sense. So basically on a tic-tac-toe board on a matrix, to check if one player has 1 or not, so you simply need to run every single time like there's a move, you need to run this algorithm. What it checks is actually every single row and every single column, like 3 consecutive, like 3 columns or 3 rows in a row. You check if they all have the same symbol. So if they are all O's, or they are all X's, as is in this case, that makes it a win. But if the board is actually full, like with O's and X's, and there is no win, there is a tie. So that's basically how you check. And of course, as well, you have to check the diagonal. So you have to check this diagonal and the inverse diagonal from this side, and just do all this checking. So there's actually a couple of algorithms. You can search Stack Overflow. There's tons of algorithms you can search from, but I've went with a simple yet really simple algorithm here. I'm not gonna just go and copy this step by step. I'm just gonna copy paste it because it's just an algorithm. It's a general one, and of course you can figure it out on your own. It's not related to Socket.io or something, so I better just go copy paste this because it's quite some long like code. I don't want to make the video really long, and of course you can simply understand this, guys. So I can go ahead and paste this one in here, which is a function, and this function what it takes, you give it a matrix and it returns true or false. So this matrix in here is going to be our plain matrix, and it returns true. For that means the first player, like the current player, has 1. It returns false, which means like the opponent hasn't won, and vice versa. So this returns false in here, which means the current player hasn't won, but the opponent has won. So we can send him like a Socket.io message, say, oh, you won, or something like that. You know, just something pretty simple. But of course, there's plenty of stuff that happens from this side to check if one player actually won or not. So for this particular perspective here, what we're doing is actually going to looping through this. We're going to use since a matrix, so we use a nested loop. So we loop on rows and columns, and we like basically push every single row. So the value of a single one, you can imagine this like as O or X. And here we check on every row. So if the value of every row equals the current player symbol, which means the current player has 1. Otherwise, if it doesn't equal that, so I'm just like using an alert in here just to demonstrate that. So that means the other player has 1. And that goes the same thing. So we basically here we check rows, and here we're checking columns as previous in here. And the last part in here, we're actually checking the diagonal. So we're basically checking the normal diagonal from 0, 0, 1, 1, and 2, 2. And we're checking the inverse diagonal. We're just doing the same thing with the player symbol. We make sure if it equals the same symbol or not, so we can tell if that current player has 1 or not. And last but not least in here, we're checking for the tie. So if all of them are null, or they don't equal to null basically, and there was no 1, like it hasn't been returning in here, there's no alerts or something like that, that means this is a tie. So let's go ahead and try to use this one. So check game state, and for checking a game state, so as soon as there is an update that happened, so as soon as the game matrix is going to be changing, so we're going to run this particular update. So what we can do is actually use the use effects, and so as soon as the matrix changes, so I'm going to do like game, or what is that, check game state, and of course we need to pass it in with our matrix in here just to make sure. Alright, so that should be all good in here. So let's go back in here and let's go into having both of these opponents. I'm gonna like refresh, have game 1, and game one here. Now if I go start with this one, put X in here, say this one O, this one X, this one O, this one X. There you go. You got current player 1. We got it from this side, and you don't get it from this side because it's not being sent over the pretty much the network or the socket server to tell it, oh, the other player has one, so you need to stop the game or something. And of course, you can have all of these criteria in here. As clear say, as soon as I played in here, say like other player 1 or something, so it just like it double checks as well as soon as the matrix updates. So we can have this a little bit differently, so it behaves as soon as there's an update, so we check for the game state, if that makes sense. So we can, for example, have it check the game state here as soon as the matrix changes, so you can do like check for a new matrix and set player turn. And the other part, what we want is actually on an update. As soon as we update all of that, we're gonna check the game state as well with the matrix, or more particularly with the new matrix. And we can completely ditch this off because it doesn't seem to be working absolutely fine. So we can go back here and here. So refresh, go game one here. And what I like about this is actually the waiting message and where you can play anyway. That looks pretty sick. So you click X, O, X here. Let's try a diagonal right now. So you get the X. Yeah, I don't know why the diagonal doesn't seem to be working, or the game state is not being checked out. Maybe. Yeah, I guess there's something, because it doesn't update with a new matrix or something. And basically because we don't have like an LRs here on the diagonal side here, that's why we don't see the LR, but it's still working absolutely fine from this side. So what we want particularly is actually whenever one guy wins, we want to send this over the network and we can stop the game and we can inform all the users that this guy has won. So to do that, that should be pretty simple. We can just gonna have into the server, we can go to the game controller and we can have like an on message. So for example here, we'll listen for a message, win, or like game win, something like this, game win. So you can have a server. So we get the game room, and for that we just go ahead and do like on the game room, we do like on game win, which is a handler, and we can pass in the same message. So that's basically what it's going to happen. It's going to just like forward the same message in here as we do the update game. Now if we go back right over here, we can have on the game service, so here public async game win. So we can have socket, and we can have this is not an on, so we can have just like a message is going to be sent, just like a string is going to be sent, I think. So for this, I'm going to do socket.on game. I think I named this game win, right? And I'm going to send this as message, which is going to be the actual message. I'm going to emit this, sorry, not on. I'm going to emit this particular one. And I'm going to have another one, which is like a listener. So I'm going to do on game win. So we can have socket, which is the socket one, and a message, or this one should be the listener, sorry, which is going to have the message, of course, as a string, and it's going to be a void. And this one is going to be socket.on game win. And of course, we can just have in the, I think I got the message there, so we need to destruct the message. And you can pass it into the listener as a message. Alright, that should be pretty simple enough. We go back to the game, we can have another handler of this side, and we can do handle game win. You can call it however you want, but I think that's a good name for it. So socket service dot socket, and you can do game service dot on game win. So we can socket service socket, and we can have a message. And simply what we want to do is actually set game started to false, so we can I think we can stop the game this way, or we can have another flag. I think we can do like set player turn to be false, so we can completely ditch the player turn. And after setting that, let me just go back here, and I can alert with whatever message I'm gonna receive. Okay, now the handling part we're gonna be sending the message on is actually whenever we check for the game state update, right? Now I want to completely ditch this off, so I can completely get rid of these alerts here. I don't need them anymore. And so this tie in here, so for the tie we're going to be returning is actually both true. That means there is a tie. Or I think if you return both false, I think both true will make a little bit more sense than both false. Here I'm checking for the game. Okay, so for this one I can do const current player 1 or other player 1. Okay, because this returns an array, and that's what should I expect. So boolean is not an array. Why there's a, I don't know, that should be all a boolean kind of array. Okay, we can just go and ignore that without any issues. And what I can check, so if current player 1 and other player 1, so here we're gonna check for the tie basically. So for the tie we're gonna do game service dot game win, and we can do socket service dot socket, and we can basically go ahead and do the game is a tie. Okay, just send this over the network. I think that would be really good, and just like having it both sent out to the network actually. And guess here we got a tie, so we can go ahead and alert whomever made that, so we can just like allow the same message just to show the current user that this is the case scenario of it. I'm gonna have else if, so current player 1 and other player hasn't won, and not other player 1. So for this case, what I'm gonna be doing is like, I'm gonna send you1 here, and I'm gonna send over the network to the other guy. I'm gonna send basically you lost. Okay, like this, and I'm gonna copy the same case scenario here, and this just could be not, so inverse that. So I'm gonna here send so that's basically, I think that should happen the same way of like if you won. Yeah, I'm just trying to think about this, but I think this should be happening on the same page, so we don't need another scenario because that will duplicate it. And yeah, basically I think this way it should handle it properly, and it should work as charming as it should be. So on game win, so just like handle and register the callbacks over there. And yeah, so let's go and test this out and see does it does in here. So I'm gonna start the game. Let's start here. I'm gonna first start with an X. All good. Check game state is not a function, or its return value is not iterable. Yeah, there's something wrong with this function, I think. So I should be always returning something, right? I think I'm not returning always in like an array or something, so that's causing an issue. So I guess that should fix it with just like returning an array, because that would default return like an empty array of I think that should return an array of both false. Alright, if we go back. I'm gonna refresh both in here, start fresh. It's better starting fresh. So X here, let's have an O on top. Let's make this player win. So I'm gonna have another X, O, X. You say you won, but we don't have in you lost, kind of like message. Of course, this has been stopped, but here is still giving us you won. That's basically, I don't know why that's not being sent out to pretty much over the network. So it's my bad actually here. I forgot about the on win, because in here our server is sending on game win instead of like game win only. So that should basically fix it, hopefully. So let me just gonna try and start from scratch. So game one, clearly open some console just to debug how that works. So start X, O, X, O, and of X, you get U1. The X is there is being completed. As clearly see, as soon as this goes A, because that's how browsers basically works with the alarms, but it should work really well asynchronously, and it should work like real time. So clearly you get here you lost. Of course, if you win from this part, you're gonna get you lost in here. You're gonna get the you on tie. That's all gonna work perfectly fine. So that's looking absolutely great. I do love actually working with this, and it's a real word game. Clearly on the browser using Socket.io, React.js with Node.js. I know that's a quite long video, but that should be worth it for you guys to learn all of that in a single video with Socket.io, Node.js, Express, and React.js, plus TypeScript with really cool typed type-ins, and that should all work as charming as you can see. So I really enjoyed actually making this video. I really enjoyed playing or making this game with you guys. So I hope you guys enjoyed this video. I hope you guys enjoyed as the rest of ones. Please make sure to subscribe and push that like button, just like to, give me a push up, make more videos like this if you're really enjoying this one. And please make sure to subscribe, and hope you guys enjoyed this video tutorial as you did with the others, and hope you'll catch you in the next ones. And yeah, see ya.